Good morning, students. Myself, Vijay Shankar from DC Department, Chevrolet Engineering College. Today, we are going to discuss about another topic that is nothing but the voltage and the work done. The examples in this same third unit electrostatics. An electrostatic field is given by the E bar is given minus 8xy ax bar minus 4x square ay bar plus az bar volts per meter. The charge they're saying that the charge Q of 6 coulombs moves from B to A. What is the B point here? 1, 8, and 5. And the A point is at 2, 18, and 6. It is moved from B to A. B to A. Find the work done in each of the following cases. The first one is the path selected y is equal to 3x square plus z and z is equal to x plus 4. Path selected. Okay. The electric field or electrostatic field is given the E bar is equal to. They're asking that find the work done in each of the following cases. Work done. The following work done VW is equal to, the formula is minus Q integral uh, 6 coulombs and integral E bar is given minus 8xy ax bar minus 4x square ay bar plus az bar dot bar plus dy ay bar plus dz az bar. These are differential length in the Cartesian coordinate system. So we know the dot product itself is a 1 and other dot product is a 0. So minus 8xy dx, because the ax bar and the x bar coefficient, it is the dx. Minus again the 4x square into dy plus az, only the 1 is there, and here the dz. Got it, my students? So apply the integral with respect to the x here. 8y is a minus 6 into minus 8y is a by 2 x square by 2 and minus 4 x square. The integral here, the dy is there. Dy means y plus integral dz, nothing but is a z. Okay. So minus 8xy dx minus 4x dx square plus z, and z is equal to x plus 4. See, we got here, as in the path of minus q is nothing but the 6 from B to A and B to A and the B to A, the values. Y is equal to 3x square plus z as a path, and z is equal to x plus 4. Dy is equal to 6x plus 1 into dx. And so integral B to A minus 8xy into dx is the limitations of x values here. What is the limitations of x values given? X is for the values of 1 and the 2, and y is 18 and the 8, and the Z is the values of 5 and the 6. So the X value is from 1 to 2. The 1 to 2 we can apply here. Integral A to B minus 8x into xy. The x value is only the x square by 2 will get. And minus 4xy, the integral, the y values are 8 and the 18. And integral A to B dz, the limitations of z is equal to 5 and the 6. Got it, my dear friends? So W is equal to, the first integral is 1 to 2, and the second integral 8 to 18, and third integral is 5 to 6. Got it, my dear friends? So when using the first part, when using the y is equal to 3x square plus x plus 4, they given like that. Calculate the value for the work done of path is selected from 3x square plus z. That z is given x plus 4, 3x square plus x plus 4 here. And the dy is given as a 6x plus 1 into dx. Dy is equal to, apply the derivative on both sides. Dy is equal to 3x square means 6x plus x is a 1 into dx. And changing the limitations of y from 8 to 18, and in terms of x from 1 to 2, we get the x values are 1 to 2 minus 8x. Y I am replacing as a 3x square plus x plus 4 into dx. And for next integral is a y value is 8 to 18, but changing that value, the y as in terms of x. So x is equal to 1 to 2, 4x square. Dy I am replacing as a 6x plus 1 into dx. So change the limitations of 8 to 18 is a y, but I replace the dy as a x terms. So 6x plus 1 into dx. So integral z to 5 to 6 dz. So apply the integral here. 3x cube, 8 3s, and here it is a x cube. X cube value is x power 4 by 4. And 4 is get cancelled, is a 24 is a 6. 8 x square is x cube by 3, and x is x square by 2, and the 2 is multiplied with the 16, we will get the 32 here. And next, the terms 24 x cube plus 4x square into dx. The 24 is x power 4 by 4. Again, it is a 4 is divided with 24, you'll get the 6 minus 6x power 4, and the plus 4x cube by 3 here, 4 by 3 into x cube. Total all the values, the limitations is the same, 1 to 2, and the last one is a dz is a z from 5 to 6. So simplify this function, and work done W is equal to 1530 joules. That is for y given 3x square plus z, and z is equal to x plus 4. Okay, my dear students. The work done for the path is selected. Y is equal to 3x square plus z, and z is equal to x plus 4. And second one, the straight line from B to A. The straight line from B to A. The second case. The straight line path from B to A. To obtain the equations of straight line, any two of the following three equations planes passing through the line are sufficient. So B is given 185 and A is given 2816. So we know a straight line equation y minus y is equal to mx plus c. This is a straight line equation. Y is a y minus y1 is equal to m is a slope y2 minus y1 by x2 minus x1. And the x value is x minus x1. So this is a formula for the straight line equation. Y minus yb is equal to ya minus yb. The yb means nothing but it is a y minus y, and y2 minus y1 and x2 minus x1. You can keep that as a value. Either it is a y minus y2 also, but here the y1 minus y2 and x1 minus x2 and x minus x2. So whatever it is the same, but the negative values is will get change of the negative value. The A is 1, the B is 2 you can consider. Then y minus yb, b value here. See, the b term is a 1. The y, let us take here, these values are x1 and y1, and it is a and is a z2. Okay. Now you can see that it is a y minus y1. Y1 if I am taking as 8, and y2 is 18 minus 8, and x2 is a 2 minus 1, and x minus x1 is a 1. So y minus 8 is equal to 18 minus 8 is a 10, 10 by 2, x minus 1. So y minus 8 is equal to 5 into x minus 1. Okay, that is the first one. Y minus 8 is equal to 5 into x minus 1. For the second, z minus z1, it is z1 you can consider, that is a z minus 5 is equal to z2 minus z1. Okay, 6 minus 5 by y2 minus y1. So y2 minus y1 is 18 minus 8 into y minus yb. So y minus yb is nothing but here the 8 value. Okay. So z minus 5 is equal to 6 minus 5 is a 1, 1 by 10 into y minus 8. That is equal to z minus 5 is equal to 0.1 y minus 8. Okay, this is another equation in terms of the z values. Z is equal to y relation. Here the y as a z relation, x relation, sorry. Next, the last one is a x minus b. X minus xb is a 1. X minus 1 is equal to x2 minus x1. 2 minus 1 by, and 6 minus 5 and z minus 5. Okay, it is becomes of x minus 1 into 2 minus 1 is equal to 1, 6 minus 1 is a 1, and 1 into z minus 5. These are the three equations we got here, and using this formula, you see here, y minus 8 is equal to 10 minus, either 10 minus 2 minus 1, sorry, here the 2 minus 1 is a 1 only, my dear students, sorry. This a value is only the 1. So there is a total, that value is a 10 into y minus 8 is equal to 10 minus 10 into, not the 10 into x minus 1. And second function z minus 5 is equal to 1 by 10 into y minus 8. Okay. And these two values you get, and similarly the last equation also, the x minus 1 is equal to z minus 5. Got it, my dear students? So W is equal to minus Q. W is equal to minus Q. The integral x values are 1 to 2 and y values are 8 to 18, and z values is 5 to 6. Minus 8 into xy dx. The y value changes as now using the quadrants of A to B. The y value is 10x minus 2. You can substitute here 10x minus 2, and all the terms is dx1. Similarly, (4x square into dy). Dy means apply the derivative for this one. Y is equal to 10x minus 2. Dy is equal to 10 into dx. So the first two integrals is becomes in terms of the x values. So change the limitations of 8 to 18 as 1 to 2 only. And 5 to 6. 5 to 6 is a dz. Nothing is changed there. Okay. Then apply the integral for all three terms and substitute the values, the upper limit and the lower limit of x and upper limit and lower limit of the z, and simplify the equation, you'll get the Q is equal to 1530 joules. This shows that irrespective of path selected, the work done is in the moving of a charge from B to A remains the same. So previously we got the same thing, the 1530 joules by selecting the path. Without selecting the path also, by using from B to A, by using the straight line path from B to A, find the equations of y and the z values, not the z. Y is equal to 10x minus 20, dy is equal to 10 dx, and z minus 5 is equal to 10z is equal to y plus. We are not using the 10z plus is equal to y plus 442. So only you can changing the y and the dy. The remaining all it is the same. So both having the values of 1530 joules only the work done. Okay, my dear friends. The next example. Consider an infinite line along the z-axis. Show that the work done is 0 if a point charge q is moving in a circular path of radius r1 centered at the line charge. Centered at the line charge. This is a circular ring. Infinite circular ring with a radius of r1. A small differential length is assumed on the circular ring. The dl bar is equal to r into d phi a phi bar. Dl bar, because it is in the circular, we have only the dl bar is equal to r into d phi a phi bar. We are not considering the dr and we are not considering the z also. Okay. So cylindrical coordinate system, the line charge is along the z-axis. Dl bar is equal to r into d phi a phi bar. Next, E bar is equal to, rho L by the 2 pi epsilon naught r into AR bar is the infinite line charge along the z-axis in the cylindrical coordinate system, E bar. So using the work done, W is equal to minus Q integral E bar dot DL bar. The DL bar we know now, the minus Q, the integral E is a rho L by the 2 pi epsilon naught R into AR bar. And the DL bar also we are taking the R into D phi A phi bar. So the dot product of AR and A phi nothing but is a 0, the 0 value. This shows that work done is a 0 while moving a charge such that path is always perpendicular to the E bar direction. Okay, my dear friends. Next, coming to the another example. Consider an infinite line charge with rho L density along the z-axis. Obtain the work done in a point charge Q is moved from R is equal to A to R is equal to B along the radial path. So the DL bar now we can consider as in the AR bar direction. DL bar is equal to DR into AR bar. In the previous case, we considered DL bar in the phi direction. Consider a circular ring. In that circular ring, a small differential length DL bar. The differential length DL bar is on the circle. A charge is distributed on that circle or the circular ring. So DL bar is equal to R into D phi A phi bar. So AR bar dot A phi bar is both are, it is a 0. Now in this condition, the DL bar is equal to DR into AR bar. And E bar is also given rho L by the 2 pi epsilon naught R into AR bar. The AR bar dot AR bar is equal to 1. Substitute that and find the work done W is equal to minus Q rho L by the 2 pi epsilon naught R AR bar dot AR bar. So rho L by the 2 pi epsilon naught is a constant and the integral, the work done is equal to minus Q rho L by the 2 pi epsilon naught, the integral 1 by R, nothing but is a ln of ln R. The upper limit is a B and lower limit is a A. The work done W is equal to now the Q rho L by 2 pi epsilon naught, and is upper limit is ln of B, or it is ln of A by B. I'm changing this minus also. The W is equal to, we got as Q rho L by the 2 pi epsilon naught. When you remove this minus, it changes as A to B. A by the B. Multiply this minus ln B plus ln A. It is getting off ln of A by B. Log A minus log B means log A by B only. As B is greater than A, ln B by A is a positive and the work done is a negative. This indicates that the field is done, the work and the external source is receiving the energy. If B is greater than the A is positive, ln of B by A is a positive and work done is a negative one. Okay, my dear friends. Coming to the next example. Here, a point charge Q, 0.4 nanocoulombs, a point charge Q, 0.4 nanocoulombs, is located at the origin. Obtain the absolute potential. Absolute potential. See, what is a relation between work done and the potential? Work done is equal to, we have the formula. Now we did the three examples. That is integral E bar dot dl bar. The potential V is equal to work done per unit charge. That is equal to integral minus integral E bar dot dl bar is a formula for the potential. Okay. And at the point charge, the potential V is equal to Q by 4 pi epsilon naught R, or it is a RA. So actually it is a R only. If having RA minus RB, the VA minus VB we have. V is equal to, suppose if it is a VA minus VB, what is a VA? The Q by 4 pi epsilon naught, that is a RA minus Q by 4 pi epsilon naught RB, that is equal to the common take as a 4 pi epsilon naught as of 1 by RA minus 1 by RB. RB minus RA by RA minus RB, the both are the terms is actually the voltage V is equal to is a value, and the point charge you can take consider only the V is equal to Q by 4 pi epsilon naught R only. Okay, why I am taking the RA means the origin at 0, 0, 0 to find the distance, and A is 2, 2 and 3. So you can take the receiving end and the sending end, 2 minus 0, 2 minus 0 and 3 minus 0, you get the RA distance, root of 17. Substituting of Q, 0.4 nanocoulombs and 4 pi 8.854 into 10 to the power of minus 12 under root of 17. Got it, my distance. The relation between work done and the potential is V is equal to work done per unit charge is minus integral E bar dot dl. Okay, the point charge of the potential is Q by 4 pi epsilon naught R. Coming to the next example. If a charge Q is equal to 0.4 nanocoulombs is in the above example is located at the 233, then obtain the absolute potential of a point A is 2, 2 and the 3. Okay, the previously they are taking the origin. Now it is at the charge is at 233 and you have to find out the absolute potential at the point A is a 2, 2 and the 3. Means 2, 2 and the 3 is towards this direction. You can write as a 2 minus 2 and the 2 minus 3 and the 3 minus 3. Okay. To find this direction is a 2 minus 2 and 2 minus 3 and the 3 minus 3 to get the RA. It's under root of this is a 0 value, and here the minus 1 whole square is a 1, and here it is a 0 value, the 1 VA is equal to 0.4, 10 power minus 9, and 4 pi epsilon naught RA, the value is a 1. Okay, these are sending end and these are receiving end. The receiving end minus the sending end values, the 2 minus 2, 2 minus 3, and the 3 minus 3. Got it, minus. Coming to the next example, if a point B is at minus 233 in the above example, find the potential difference between the points at A and B. Okay, now only I told that the VAB is equal to VA minus VB. Okay, for where VA already we find the 3.595, and now we can find the VB. VA is equal to 3.595. What is the VB? The Q by 4 pi epsilon naught RB value. The B now is given 233. The previous example for A is a 22. Now assuming that it is a B is a minus 2 and the 3, they're asking the 3. So 2 minus of minus 2 is a minus 4 whole square. 3 minus 3 is a 0, and 3 minus 3 is a 0. We'll get it is a value is a 4. Okay, is a 4 only, the RB. Substituting the value of Q, 0.4 into 10 to the power of 9 and the 4 pi 8.85 into 10 to the power of minus 12 into 4. VB will get VA is 3.595 and VB is a 0.8987. Subtracting of two values will get the voltage AB. The potential difference between the points A and the B. Got it, madam? Now, coming to the next example, if there is a 3 charges located in the different coordinate systems, one is at the origin, Q1, 3 microcoulombs. Another is at 2 minus 1, 3 at 4 microcoulombs. And another one is located, the Q3 is located at the 5 microcoulombs is 0, 4 minus 2. And you have to find out the potential at the 101, assuming the 0 potential at infinite. Okay. So first of all, if I am finding the VA1 is equal to, we have to find at the A point. A point means that this is a receiving end, this is a sending end. Okay, the subtraction values of 1 minus 0, 0 minus 0, and 1 minus 0. To find the R distance, the VA is A1 is equal to, the first value, the charge is a 3 to 10 to the power of minus 6, and the 4 pi epsilon naught is 8.854 into 10 to the power of minus 12, and it is R1 is R1, the distance of 1 minus 1 under root of 1 minus 0 whole square, 1 square, and 0 minus 0 and 1 minus 1, 1 minus 0 whole square is a 1 square. It is a 2 under root of 2 value. Got it, my students? Substitute the values and calculate the VA1. VA1 is equal to 19.06 kV. And the Q2, the distance of R2 here, the 1 minus 2 is a minus 1 whole square. 0 minus of minus 1 is a 1 square, and 1 plus 1 is a 2, and 1 minus 2, you'll get the minus 2 whole square. The 4 plus 1 is a root 6. So you'll get the root 6 here. Okay, and the remaining is the same. The charge Q2 given 4 microcoulombs. The 4 microcoulombs, you substitute the value, and 4 pi epsilon naught under root of 6. Then you get the VA2 value. And similarly, the last one, the potential A due to the Q3 is Q3 given 5 into 10 to the power of minus 6 coulombs. And now the 1 minus 0, the 1 square, and 0 minus 4 whole square is a 4 plus 1 is a 5. And 1 minus of minus is a 2. It is a 3 square, 9. 9 plus 1, 10. 10 plus 4 is a 14. Under root of, the 4 square is a 16. 16 plus 1, 17. 17 plus 3 square, 9. So you'll get the 26. Okay, 4 square is a 16 plus 1 is a 17. 17 plus 9 is a 26. So VA3 we got 8.8132. Then you can find all the terms 19.06, 13.8.813 and minus 14.6. So the Q2 is given is showing here the plus. They take this a minus. Let us take if that is a minus value. Here the minus is Q2 is equal to minus 4 microcoulombs. Combination of all the three. (13.2021 kilovolts). And next example here, a point charge of 6 nanocoulombs is located at origin in a free space. Find the potential of point P is located at 0.2 minus 0.4, 0.8, and V is equal to 0 at infinite, and V is equal to 0 at 110, and V is equal to 20 volts at the point of at the location of the 0.5, minus 0.5, 1, and minus 1. So we know the potential V is equal to Q by 4 pi epsilon naught R. The first one, you can take the P is located at this value of 3 quadrants. First consider the V is equal to 0. The charge is located at 0. So 0.2 minus 0, minus 0.4 minus 0, and 0.4 minus 0. So our value is given, it is got as a 0.6. Substitute the values here for the 6 nanocoulombs, 6 into 10 to the power of minus 9. And R we got by taking off Q is at the origin. And the point P is 0.2 minus 0.4 and the 0.4 it is also. Next one, when the V is equal to 0 at 100. At 100. Thus, the reference is not an infinite. In such cases, the potential at P is P suffix P is equal to Q by 4 pi epsilon naught R suffix P plus C. Okay. I can find here for the given values of R when I'm assuming 100. So 100 means again you can take RR value, the 1 minus 0, 0 minus 0, and 0 minus 0, the value is a 1. They're saying that at this case, the voltage is a 0. So what is the voltage is a 0, and 6 into 10 to the power of minus 9, 4 pi into 8.85 into the power of minus 4 into 1. I take it is a plus C. The C is equal to. So what they're asking here, the V is equal to 0. Find the potential V is equal to 0 at 100. Means the V suffix P is equal to 35.950. By adding of this term, for V suffix P 89.8774 we already got, and subtract the 3 C value here minus 53.9. Totally will get 35.9509 volts. This is with the reference of 100, where the voltage V is equal to 0. And the last case, V is equal to 20 volts at minus 0.51 minus 1. The same thing we can consider V suffix CM. VM is equal to 20 volts. Substitute the 20 volts here. And at that, the 2 points here, minus 0.5 and the minus 0.5 here, the 1 and the 1 and minus 1 whole square. Okay. So from minus 0.5 minus 0 and 1 minus 0 and minus 1 minus 0. So we'll get the Rm is equal to 1.5, substitute here, and we'll get the C. And V suffix P is equal to, you can add the value with the 89.8774. Already we got with the reference of at the infinite 89.877. You can subtract the value of minus 15. The V suffix P we got as a 73.9. Note that the distance point P from the origin where the Q is located is R suffix P, which is same as in all the cases. 73.9 here. And another one we got as 35.9. And it is a 89.8. Okay. And coming to the next one. Find the potential V on Z-axis at a distance of Z from the origin when the uniform line charge is a rho L in the form of a ring of radius A placed at the Z is equal to 0. So we already did this example. A circular ring, you can assume a small differential length on the circular ring. The DL bar is equal to R and the phi ohm. So DL bar is equal to R into D phi. R into D phi A phi bar actually. Okay, a point on the Z axis means 0, 0, Z. And a uniformly charge is distributed on this means AR component is eliminated. AR component is eliminated, my students, in the circular ring. So see, the under root of A square plus Z square only we got because the 0, 0 point and 0, 0, 0 Z. One is A is a distance here. A is a distance and plus a Z square, a point Z here. The 0 minus 0 and A minus 0 and 0 minus Z whole square. You'll get A square plus Z square. So rho L dq is equal to rho L into dl. Then substitute in the voltage V is equal to the point charge Q by 4 pi epsilon naught R. And the differential voltage means the differential charge you can take. That differential charge in terms of the line rho L into dl by the 4 pi epsilon naught and R we got as under root of A square plus Z square. Since the values are 0, A and another one is a 0, 0, Z. You can take under root of 0 minus 0 whole square and plus the 0 minus A whole square, it is a A square, plus Z minus 0 whole square, it is a Z square. Okay. DL. And what is a DL? DL is on the ring means R into D phi. What is R here? The distance is A only. So rho L A into D phi. I am substituting as DL bar is equal to and 4 pi epsilon naught under root of A square plus Z square. Okay. We got this function as of V differential potential V dVA is equal to. Now I can apply the integral on both sides. VA is equal to. In the right hand side is with respect to that phi only, the remaining all it is a constant rho L A by 4 pi epsilon naught under root of A square plus Z square. And phi is the integral d phi is a phi, upper limit is a 2 pi. Substitute the 2 pi and get cancelled. Here the 2 pi will get with this substituting the 2 pi get cancelled with the 2. So rho L A by the 2 epsilon naught under root of A square plus Z square. The potential is equal. Got it, my students?